Hey, Exploring Life Science, it's Miss Shattery with our first set of notes for our new unit, which is going to focus on environmental services and technology. We're going to be focusing mostly on the soil and some of the different ways that we interact with the soil, and also help protect the soil using some different technologies. But we've got to start with the foundation, so we want to start with an introduction to soils themselves. So, those of you who talk to any of the upperclassmen will probably know that Miss Shattery has this thing about soil and dirt. Soil is not dirt. Dirt is the stuff that gets stuck under your fingernails or on your skin. It's what gets all over the floor in the house. Soils are entirely different. Soils are layers of organic and inorganic materials that are able to support plant life and lots of other life because of it. Soils are beautiful, they're vibrant, and they're valuable and super important to life on this planet. So they're not the same thing as dirt. As we move forward, one of the things I want you to focus on is using the word soil in the right context and the word dirt in the right context. Vocab is important. So, soils. Soils consist of four basic parts, and the ratios of those parts and the stuff that's found within individual parts can be really different, but same four basic things. First is inorganic materials. Okay, these are things that have never been alive, things like rock, sand, silt, clay, minerals, etc., that come from those rocks. Okay, that's the inorganic part. It gives soil most of its structure. We also have organic materials, or things that come from organisms that were once alive. Okay, dead plant and animal matter, all of the nutrients in their body that help to supply nutrients into the soil. We also have water. Okay, all soils need to have water, otherwise they really are just dirt because they can't grow things without it. And air. Okay, we don't tend to think about there being air in soil when you scoop up a handful of it, but really you need to have air there, otherwise it's too compressed for anything to grow in it. P.S. This is a reminder, if you haven't found a container for soil sampling, like a nice jar or something, work on saving one somewhere from your kitchen or rescuing something that's a clear see-through container that you're not going to get in trouble for putting soil in. Okay, so how does soil form? Why does it form? How long does it take to form? I want to start with a little bit of a history background. So, man first walked on the moon in 1969. The Wright brothers flew their first successful-ish flight in 1903. The United States was officially formed in 1776. The first Thanksgiving was held in 1621. And the amount of time that it takes for soil to form could be far farther back than any of those things. Depending on the conditions, it can take anywhere from 100 to 1,000 years for just 1 inch of topsoil to be found or to be created for the planet or for the surface of the planet. Okay? There's lots of different factors. We'll talk about them in a moment, but soil doesn't get produced quickly. Okay? There's lots of things that need to happen in order for all of those elements to be present, especially that inorganic part of it, having those broken down like rock materials. And so it can take a good deal of time. This is why in our natural resources unit, when we talked about, is soil really a renewable resource? Well, it is and it isn't. We can reuse the soil we have, but it does break down over time, and it takes a long time to replenish what gets destroyed or degraded over the years of use. So, what affects soil formation? The number one biggest thing that affects soil formation is the climate. Okay, what are the conditions, like the environmental conditions in that specific location? Okay, climate varies drastically throughout different parts of the planet, and that has a huge effect on how quickly or how slowly soil forms. Generally speaking, the warmer a location is, the faster soil will form, and the wetter or the more precipitation an area gets, the faster soil will form. Okay, it's much easier in places where it's warm and it's wet for there to be movement, for there to be growth, for there to be all of these things that cause rock to break down into little pieces. Okay, The type of parent material also plays a role. So, what what kind of rock or what kind of mineral that inorganic material is coming from. Something like a limestone is a lot softer. It's much more easy to break down than like granite or quartz. And so that parent material is going to break down much more easily. Shales will break down more easily, etc. Okay? The topography of the land or the slope of the land also plays a role. Okay, if you have areas that have higher elevations and more slopes, it's much more easy for the movement of water and sometimes the movement of wind to cause like bits and pieces of that parent material to break up over time because there's more water moving across the surface at like a greater speed. So that will cause more soil to be formed more easily, although then that soil is at the bottom of those slopes and nowhere on the top. Um, the presence of living organisms also plays a role. And the more living organisms you have reaching into that soil, living in that soil, the more likely they are also going to be breaking down parent material. And also, the more they're going to be living and dying and themselves breaking down to provide nutrients and the organic elements of that soil. And then obviously, time affects soil formation. The more time, the more soil formation occurs. Okay. So this is kind of just a little overview of how soil forms over time. You start with like just a big chunk of rock, okay, and water hitting that rock, wind going through that rock. All of those things are going to cause a process called weathering, which causes the rock to break down into pieces. Okay, over more time, that breakdown gets deeper and deeper into the soil. You can kind of see that on these pictures. And we see the formation of what we call horizons or different layers in the soil, which I think we've got a little bit of a note on in a little bit. Okay. You can also see as we start to have actual soil at the top of the surface, we can start to have small plants grow. As they grow, their roots work into the soil, they have and contribute to more breakdown, which allows bigger things to grow, deeper root systems that help to continue to break that down over time. So we have, because we've got a little bit that gives us the conditions to have organisms there that are going to help to break down more over time. Okay. Soil formation, again, happens due to a process called weathering. Okay, weathering is the breaking down of that parent material. Weathering happens due to a number of different phenomenon, but regardless of what's happening, it's just that breakdown of bedrock into smaller and smaller pieces over time. This is the process by which the Grand Canyon, which is what we've got a picture of over here, that's how that was formed. Okay. In the case of the Grand Canyon, that was formed primarily due to the movement of water. But there's lots of things that cause weathering. Okay, freezing and thawing is a big one in our area where we get like really cold winters, and then things like seize up and then thaw back. And so that movement, the freezing, the thawing, causes the particles in the rock to like expand and contract, and that can cause breakdown. Same thing with heating and cooling, water and wind erosion. So the movement of water and wind along like bare surfaces, like in the Grand Canyon, cause bits of rock to break down over time. Water leaching minerals out of something, so like the water pulling minerals out of the rock itself. And then also the presence of animals and plants, their movement against rock, plants' roots going into rock crevices helps to break them down. So weathering is the breakdown of parent material. Soil, part of soil production, part of soil movement is then also the processes of erosion and deposition. Erosion is the movement of soil from one place to another, usually because of wind and water or slope. And then deposition is the dropping or the depositing, really, of soils in a new location. And so that helps to form topsoil in new places. So if you look at like our image here, if we had a big rainstorm along those cliffs, the movement of that water, hitting the bare rock and then sliding, moving down the bare rock is going to start to dislodge pieces, and then it's going to deposit new soil at the base of that canyon. Okay, so that's kind of just our basic introduction to soil. We're going to look at all the different characteristics and qualities of soil in another, I think, 2 days. Tomorrow, you're going to start setting up a soil lab So if you have any questions about any of this, please let me know. Otherwise, I hope you guys are well, and I'll talk to you later.